thank you, Christoph, for the invitation into a session that we're going to explore open source tools that will help you deploy your robotic application using Ubuntu. My name is Gabriel. I'm the Robotics Product Manager at Cannonical. With me today is also Jeremy and Florencia, engineers, part of the robotics team. This talk is for all of you deploying or thinking to deploy robots and answer that question. Is there an easier way? Today, several companies are deploying robotic solutions using our OS, Ubuntu, where many open source projects found a home, like ROS. ROS and Ubuntu have been together since the beginning. More than 10 years ago, the very first release of ROS, Box Turtle, was built on top of our Ubuntu hardware. For the past decade, we have been supporting natively ROS on Ubuntu, which enables innovators to keep pushing the boundaries of robotics with our OS. And we love to see people developing robots using Ubuntu. That's why we want to help them get also to market faster and reliably. Because making robots is not easy. There are several challenges when prototyping and developing robots that we are all aware, from long-term autonomy to learning on the job, scene awareness, and more. So under these conditions, it's understandable that we sometimes forget or do not prioritize some deployment requirements that you need to go to market. And today we will talk about these two big challenges that we have seen out there with companies, because if not taken into account, they could delay entry into the market, hamper profits, result in higher support costs, and cause their own set of technical problems. So right now, ROS is in that stage of going into market, and these factors are important and relevant for all of us. It doesn't take long to find an example of companies who start shipping their devices without considering the need to update them or having a reliable update system. From small to big companies, this is a challenge for all. And building and maintaining your CI/CD infrastructure is difficult. You should consider expenses, maintenance costs, and scalability. You should develop or adopt a robust and reliable system. If it has been tested on the field, that is even better, but this could be expensive. And ideally, your software management infrastructure will provide consistency between your development environment and your deployment environment. Today, sending field engineers is one of the most opted options, but it doesn't scale well and quickly become astronomically expensive as the number of updates or the number of customers rise. Firmware downloads scales better, but it requires the engineering of infrastructure to host the update, as well as software to robustly apply it. Then it's also the ability to seamlessly be able to update devices without downtime for the customers. Over-the-air updates with a transactional path is part of the minimal infrastructure requirements to update devices that is expected nowadays from all of our customers, not only on the industrial side, but in many other different fields. Security is another key factor, but I won't talk about implementing security policies and hardening techniques here. That is a topic for tomorrow's session, where we will share recommendations from our security experts here at Cannonical. Instead, I will talk about common practices that we see today in many ROS companies, in many ROS projects, where basically they are forking upstream and maintaining their own pool of devs that then they make available to their customers. I say maintaining because normally companies do not touch this fork until there's a major feature update that they want to implement. But what about security updates? So recently, Open Robotics registered a new CVE that affects ROS kinetic, melodic, and noetic. And the question is here, have you implemented that security update? Have you made it available to your users? Companies that update their forks in this 6-month window probably didn't. And this missed effort for actively looking and patching vulnerabilities could become a danger to our company, to your company, and to your users. And for those using ROS Kinetic, since it's end of life, the mentioned CVE patch is not available. So what then? So take, for example, Astrobe, the robot that Dave Coleman just mentioned. That one is running ROS Kinetic, end-of-life distribution. Between R&D and the deploying of devices, maybe 5 years is not enough time of security maintenance support. Maybe we're looking for something longer than that. Because security maintenance is the essential requirement, and if you don't have this, you are likely to hit a wall soon. It's not only the cybersecurity regulations that we have right now in industries that requires this as the first step, being able to send updates, security updates to your devices. If you follow the CIS or the NIST cybersecurity regulation frameworks, or if you're working on specific industries, they have their own regulations. So for example, take healthcare, where they work with HIPAA, or the credit cards, where they work with PCI. So all of them are requesting this upfront. And we also start seeing governments that are requesting the same from manufacturers to tell customers upfront for how long a device is going to keep receiving security updates, because that's the minimum requirement that we have to think of. So to help all of our developers that are working today with Ubuntu, we made available 3 key technologies, 3 key open source technologies for ROS and robotics: the Snaps, the Snap Store, and Ubuntu Core. A company using these open source tools has the infrastructure to solve the mentioned challenges. They are fast and easy to use. They use a reliable infrastructure that today is globally used by millions of Ubuntu users. And these tools are maintained by us, by Cannonical, in the same way that we maintain Ubuntu. So how do they work? Well, imagine that this is your ROS workspace with all your nodes, topic, and all the ROS packages that you are using. Snaps offer a reliable process to bundle packages together with all their dependencies. It creates an immutable container, adapting to the way that you're using ROS. Because snaps have been optimized for ROS thanks to dedicated plugins that allows an easy packaging, reducing building time, and also runtime of ROS applications. But most importantly, snaps were designed for embedded devices. Out of the box, snaps provides dedicated and maintain interfaces to access the host machine and its resources, because they were designed for this kind of interaction, something that other containers don't. So if you need easy access to GPIO pins, there's an interface for that, and you don't have to be hacking your container to get that access. Together with the Snap Store, you have all the infrastructure you need to manage software updates. So with a simple command line, your application will be sent to your device. This is the front end of the Snap Store, a platform to manage software installs, like I was mentioning. And here is where your Snap could live. With the store, you unlock some essential infrastructure to manage software updates, such as scheduling updates, assigning a set of snaps to a specific robot, a set of specific robotic applications to a robot, also global consumption metrics, and more. And I want to show you a video of how easy it is for you, for robotics user or your team, to start using snaps. So we will see how to set up a computer of the TurtleBot 3 from a fresh install, and we'll come on the left side using the snap, and on the right side the traditional way, the way that we do it today. I'm going to accelerate a little bit the video because it's going to take a lot of time. So with just a simple command, sudo snap install and the name of your application, it's all your users will need, it's all your team will need to deploy your package, your container, your ROS application into the device. As simple as that, compared to the traditional traditional way that, as you can see, takes more time. So let me just show you, and the robot is there perfectly running to run the teleoperation. We have, if you are not aware, Ubuntu Robotics channels that you can follow us for more of these videos. So let me just move on. Snaps can be used on desktop, but we have something better for you, something designed for embedded devices, that is Ubuntu Core, a lightweight multi-platform version of Ubuntu designed specifically for embedded environments. So it's a minimal image of Ubuntu with only the packages needed for this deployment scenario. So it's going to be an image size of less than 260 megabytes. It's even smaller, of course, than Ubuntu server. And as you can see, the OS, the kernel, and the apps, all of them are packaged as a snap. With this, there is a clean separation between the base system and the applications installed on the system. So even if there's a breach, a vulnerability in your application, the attacker will operate in a sandbox environment. Besides that, our OS, Ubuntu Core, provides all of these security features that includes as well App Armor, C groups, and more. And the best thing is that it comes with 10 years of security maintenance from us, from Cannonical. So let's mention all the features and tools that you can get today using the Snaps, the Snap Store, and Ubuntu Core. So first, with the Snaps, every update preserves the previous version of code and data. So you can safely move applications forward and backwards in their version history. You also have a rich semantic channel, which every snaps can offer multiple stream of updates. So out of the box, you can assign a specific ROS application that you develop a different version through the use of tracks. And by using risk levels, you can establish if it's stable, candidate, beta, and edge. You can also have branches if you want to deploy bug fixes to your users. Snaps have automatic recovery mechanisms. So if an error happens at any point during an update, Ubuntu Core will stop and revert to the previous working version. So if you are updating a robot and for some reason the robot turned off, your application, once you restart it, Ubuntu Core will see that the application is broken and will revert back, will jump back to the previous application that was working. All of these reduce downtime. You also have Delta updates, which reduce bandwidth consumption, which is another operational expenses for companies that you need to consider. So only the parts of the code that have changed between different versions will be updated. The content that ships inside Snap is compressed as well and remains compressed and remains read-only through the whole lifetime of the Snap, even during normal use after installations. This means the original package, digest, and signature is never touched. So it's this immutable disk that you have. And all the benefits that we have described applied as well to the kernel and to the OS. All of this reducing, again, downtime for your devices. And thanks to Snaps, developers can unlock a modular architecture where by creating a foundational ROS Snap, they can provide to your own teams, your community, or your users all they need to develop applications for your platform easier. And all these tools, again, are available today, free. You just have to download them and start using them. They will make your job easier, as they have done it for many other companies that today are using this combination of tools. There's a lot of tutorials that are available in this presentation, and if not, you can either send me an email to me or to Christoph. I think that he could help me with that as well, for you to get started with this, or just simply Google ROS and Snaps. And the second challenge that we were also talking is security maintenance. For those companies that are aware and conscious about security and importance of this, and also concerned about the time and the headcounts and resources needed to maintain their upstream pool of devs, we have a service for you. In partnership with Open Robotics, the maintainer of ROS, we provide ROS ESM, which is extended security maintenance, and ROS enterprise support for the Ubuntu and ROS experts. So overall, with ROS ESM, companies get a hardened ROS with 10 years of security maintenance. So imagine extending the life of ROS Kinetic until 2026 or Melodic until 2030. ROS now has the lifetime of your devices. So this is all the process that we do for you. This is what will help you be compliant with the essential requirement of security maintenance, from vulnerability identification to patching and testing. So no more need to hire experts, or no more need to leave your users unattended with the security maintenance that they need. Basically, we bring Ubuntu's worldwide security infrastructure to ROS. And the same, and we also include, like I mentioned, ROS enterprise support, a single point of contact for you to log any bug or that you need, especially in these critical activities. And they will be, of course, submitted to Open Robotics. For those of you using or with deployed robots using ROS Kinetic, ROS ESM, like I said, is giving this distribution 5 extra years of life, including, of course, to the OS that it's Ubuntu 16.04. And yes, the mentioned CVE has already been patched for our ROS ESM customers. Because making robots can be easier, working together, working with open source technologies. That was a quick overview of what we do. And I think that Christoph is going to be happy about the fact that I'm giving back 4 more minutes.